Okay, timers. Ta-da. So there's two basic timer styles in JavaScript. One is they're both in milliseconds, and you can set it in two structures. One is a single event timer, so you just set a timer for something and then it's done. The other is a repeating one, a set interval timer. So both of these, you need a function and a timer length, but everything else, the event is actually reading off the local computer's clock. So we're going to lift some code here. One of the places where you can do this, by the way, is in W3 schools. They have a nice, I gotta make a new tab here, but it's not as easy to do. They have a nice JavaScript compatible thing. So let's see what we got here. We want to go W3 schools and JavaScript, try it now. Right, so the try it editor, it's nice because it actually runs JavaScript, and not all of them out there do. So here we go. We can just lift any of this stuff. So we'll pull this code. I think we'll want to embed it in a script tag, though. Okay. And then we could just lift this straight from the slides. Oh, I do have a script in there. That's fine then. Okay, so I do this, I have three things. Number one, I have a paragraph. The paragraph has some text, says click, try it, wait 3 seconds, the page will start, will alert hello. Okay, so that's a paragraph tag. The next one is a button tag. Okay, and that button has the very simple command on click, set interval F3000. So it's going to be a cycle that repeats every 3000 milliseconds, every 3 seconds. Okay. And this is the script. We have our variable x initialized to 0 and our function f. Okay, so f, what it does, it increments x and then sends out an alert. An alert is a little pop-up in your window that says this is alert number whatever, and then followed by x. So it'll start off with number 1 because we increment it from 0 to 1, and then the next one 3 seconds later will be 2, and so on and so on. Okay. So that's what happens. It's going to call this this function with the number 3000. All right, so let's do it. Okay, so right now nothing's going to happen, but if I wait a little while, and now I click. And we're going to see a wave of alerts. Alert number 1, okay, great. Alert number 2, thank you. Oh, hooray, I'm getting more alerts. That's good. Glad to have them. Okay, so you get the idea. So that's a timer. And of course, timers are useful for lots of things. For example, if you were writing an exam on Blackboard, you would want to have an associated timer on that. So JavaScript will let you do it. So the events don't always have to be triggered by some user action. Again, they can be more passive in the sense that timers are going to happen. And obviously that's useful for a lot of online games, for example, when you want things to happen not instantly, but at some predictable rate. So, you know, if you have, I don't know, your dude's running through some area and you don't want him to just teleport from one side of the screen to the other, right? You want him to basically move so many pixels per second. You can enforce that with timers. All right. Now, JavaScript variables. So remember, in JavaScript, a variable can be any supported data type, right? It could be a number, which could be either an integer or a floating point number, that is a number with a decimal point. It could be a Boolean variable, which is just holds the values true or false. It could be text, right? Basically a string. And it could be an object or an array. So anything that's supported in Java, all of those are bundled together in the type var. Now, usually vars must be declared before they're used, right? So var x indicates that x is a variable. Ta-da. The exception is if a function receives a parameter, right? So you may recall from Java, or those of you that are taking now, you know, are seeing it right now. When you have a method that accepts a parameter, the type is always declared in the inside the parentheses following the method name. But in JavaScript, it's different. Reason is, since everything's bundled into var anyway, there's not any compelling reason to identify things as one or the other, right? Because JavaScript is just going to know. It's going to be context dependent what type it is. So if you have a function, here's our function f1, and it accepts a parameter z, okay? It knows, your browser knows that z is a var within that function. Likewise, if you have this thing f2 that accepts var z, that's not going to be valid. Why? Well, because var, it's looking for the name of the variable there, and then it sees that the name of the variable is var, which is a reserved word. Yeah, so it kind of falls apart at that point. So, like I said, in general, variables, you have to declare them before you use them so that it knows, it's a variable, not a function, not ordinary text. But if you're receiving it as a parameter for a function, then you just use the name. You don't have to specify that it's a var. And basically, that's done just to save space. Okay. Next thing, JavaScript math. So JavaScript's math is conformant with most other major programming languages. This is if you've done Java, this is all going to be very familiar. So first of all, you do the values inside parentheses, starting with the most deeply nested, and then left to right for those at the same nesting level. Okay, so for example, do this in. For example, if you had some var x equals 0, var y equals 1, var z equals 2, right? And you had some var function, I don't know, var math stuff equals right? We'll leave it at that. It doesn't have to be super complicated. Here we have two sets of parentheses nested inside this one. Okay. So let's copy that into Paint. Okay. So of course, the stuff in this parentheses calculated first. Okay. Over here, stuff inside these parentheses is calculated second. Okay. Then order of operations multiplies this by the parentheses, right? So I just say everything that is in here, let's give a new color. Sure. Is going to be third. Okay, and then last, whatever this total comes up to, we multiply by 2. So nested parentheses happen first. When you have multiple ones, they go left to right, right? So this one happens first, then we calculate z times z, then we calculate the whole contents of what's in these parentheses, and finally we take that quantity, multiply it by 2, and assign it to our variable math stuff. Okay. So first, that's what we do the stuff in parentheses, and then left to right for the same level of nesting. Second, multiplicative operations, right? So any operations involving multiplication, division, or modulo. Modulo is just the remainder after division. They go left to right as they appear. And last, anything with addition or subtraction, again, left to right as they appear. So within JavaScript, any arithmetic expression must be fully evaluated before being assigned to a variable. So if we go back to Paint here, this entire expression, this whole big ball of wax there, all this has to be calculated before it's assigned to math stuff. Okay, so that obviously, I mean, I hope it just makes obvious sense that you have to figure out what this entire expression on the right evaluates to before you take that quantity and assign it to math stuff, right? You wouldn't start with give it the number 2 and then multiply it by these other things. because that would entail a lot of extra steps, right? You just calculate this expression, the entire thing in the green box, the result gets assigned to the variable. Okay. We'll do some examples. So let's go for it. What are the results? What's this first one? What's the math on that? Well, let's copy these into, oh, somebody's doing a chat bomb there. Somebody says 12. Yes. Well, for those of you that are in my IDS 201 class, you've seen these before. No point reinventing the wheel. I use the same numbers for a lecture in my Java course that we just did Friday. So, results of this first one. First, we do the multiple. Well, let's put it all in. I'm going to grab it and put it in Notepad so I can edit it a little easier. Okay, first one. Yeah, we had a chat bomb in there, said he's 12. That's great. So the way we do this, first, 5 times 3, that's 15, minus 3, right? So addition, multiplication, and division left to right. Okay, they're equivalent. It's just the multiplication happens first in the calculation, the division happens second, right? And then afterwards we do the subtraction, we get 12. This second one here, okay, take a minute, look at it. What's that going to be? Yep. Boy, everybody's getting this one. Ooh, interesting. So yeah, we got some stuff here. Okay. Well, it's worth noting for those of you that aren't in the know, this is a little different from Java. Okay. In this one, we have parentheses first. So we have parentheses first, then multiplication and division left to right. Okay, so what we get here, 5 times negative 3 divided by 2. We do the math on that, we get negative 15 divided by 2, which, just like the real world, equals negative 7.5. Okay, now those of you who have had Java, I'll say not like Java, where the fraction would be truncated, right? Would be dropped. Reason is our var type can hold the integer and the floating point number. So there's no problem converting between the two. But there is a problem with the screen running over. No problem converting between the two. Okay, so our actual number there, negative 7.5. Okay, last one. What do we have here? Well, this is actually an easy one. You take a moment, but let's do it. So what do we do here first? Well, parentheses first, division, then subtraction, right? So first we have 5 times what? 3 minus 3. 6 divided by 2 is 3, which of course gives us 5 times 0, which just equals 0. Ta-da. Okay. Yeah, we got some interesting stuff here. That's okay. All right. Questions on any of these? This is just our intro to some math. We're going to pause the screen share for a moment. Okay, so let's do this. Everyone in the meeting. Okay, so key takeaways. Order of operations, parentheses first, then multiplicative, then additive. Okay, all right, that's our takeaway from that. So normal circumstances, we would have an exam and there would be questions about order of operations, and even though they're easy, people would get them wrong. But we're not doing this first module, so just make sure when you write your JavaScript code, you pay attention to that. Okay, well, let's move on. Also, again, I guess, difference from Java, right? Var encompasses all types. So the whole precision issue, typecasting from Java is a non-issue. Okay, if you didn't take IDS 201 from me and you wonder what I'm talking about with this Java stuff, don't worry about it. But for those of you who have, and many of you have, you know, you don't want to use your Java habits here, all of them, because it's a different language. Okay. So that's our, those are our JavaScript math examples. Let's move on. So here's some stuff. Here's a big slug of JavaScript code. I'm just going to lift this and paste it into the try it platform. Where's my, do that again. Try, yeah. Okie doke. So we're going to do this. Boom. Okay, so let's run it. So here we have my first JavaScript, and we can do some simple math in it. So here I have 3 buttons. One is labeled reset, one is labeled increment, one is labeled, oh shit, I'm not screen sharing. I got a screen share. All right, well, let's do that. Can't see, right? We're going to share. Okay, so here I have some JavaScript that I just pasted in. So this first one, again, is a reset button. This is an increment button. And this is a decrement button. Okay, and that's it. That's all the stuff I got on here. And then I have a paragraph tag here labeled demo. That's where I will display the results. So initially, right, this is my script. I set x to 0. I call this show x method or show x function. And show x just displays the value of x, my var, in the inner HTML. So the inner HTML of a paragraph is just the text that would be there. That's what's between those 2 p tags. And when I click any of these buttons, for example, if I do this one, right, if I do reset, I set x to 0 and then display the updated value of x, right? So here I have this function set x to y. It just says, boom, x equals y. This one, increment x, right? I add 1 to x, x plus plus, that means add 1. And this one, decrement x, dec x, I call that one, and I decrement x. X minus minus means subtract 1 from x. So if I wanted to, I could increment it a few times, la, 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 la. I could decrement it a few times, la, 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 la. Okay? If I wanted, I could reset it back to 0. Stuff happens, okay? Basic math. Now, I could add on other buttons if I wanted. For example, right, I could do 2 things. I could show an X and a Y. Let's do that. Okay, so I'm going to add on a few things. So I'm going to create a var Y also equals 0. Okay, and I'll do show Y. Okay, let's make this. We're going to do some things. We can do some simple math. Okay, let's change these a little bit. Okay, and we are going to need a couple of other things here. So we're going to have a function, all these. We're going to do equivalent ones for y. do a couple more here. We can't do y, can we? I gotta flip that. Let's do z. X equals z. Okay. So var y, show y, inc set, back set. Okay. I already have one for that. Okay, set y. Do again. Some number z. Okay, and then these I'm going to copy for x and y. Let's see, so we have set y to 0, we have increment y, we have decrement y. We're going to go to show y, show y, show y, reset y. Okay. We're going to do another paragraph tag. Basically, I'm just doubling up all this stuff for a new variable. So I'll call this demo x, and I'll call this demo y. Here we have demo x. And I'm going to do a show y function. Okay, let's see. I think everything's good here. Inc y, dec y, set y is 0. Okay, let's make sure it runs. Ah, that's good. Okay, good. So no mistakes. If you made some mistakes, if your code is a little bit sloppy in there, then yeah, none of this is going to run. Okay, but now I have my x and y. So I can do this. I'll even put in some text. Okay. Whoop. Okay, and then here I'm going to do this. Okay. There we go. Wonderful. Okay, so our stuff is changing, and that's good. Now, if I wanted to, I could add on a couple more buttons, right? I could add on, well, I could add on some multiplication or some division. Let's do one of both. Okay, so button type. Okay, we'll call this, I don't know, XY, and here we'll call it, let's just call it molt XY, and here we'll call it divide X by Y, okay? And then we'll do show X and show Y. We'll put all those in there. No, we're going to show XY. That's what we want to do. We want to show both of them. Just want to show, yeah. And here, I guess we'll call it show XY. Not the best one, so. And here we'll call it X divided by Y. Okay, I could come up with some better function names, but this will work. Okay, so I have a show XY, so I need to show X and Y. So I'll have another demo tag here. I'll make two more. Call this demo XY, and initially it will be blank, but I can set the text as appropriate. Okay, so we have, I just need to put in these two more functions, show XY. Right. Yeah. I call this show molt. show molt, and this I'll do show div. Okay. So basic stuff here. Let's do these two functions. Okay, so I'll do, what is that? It's called show molt. So again, the element that I'm using is demo xy. The inner HTML, I'm going to set to x times y, and that will equal plus the quantity x times y. I can scratch that over a bit. Likewise, show div. Okay, document demo xy, and the inner HTML on that, I'm going to do x divided by y, which will equal plus x divided by y. Okay, so let's see how this goes. I think this is all good. We'll give it a try. Okay, it's still happy, so I'll push this down a bit. Okay, so let's do increment x and decrement y. Let's multiply them. Oh, I didn't like that. What happened? Show molt, show molt. Oh, that's because there's no method there. That's right. So that kind of crashes. Okay, I don't need to do any math there. Let's try again. Okay, so I'm going to increment x, decrement y. There we go. X times y is -1. I do a divide. X divided y is also -1. Let's increment y again. Let's do a divide by 0. See how it handles that. It gives us infinity. Yeah, so divide by 0 errors. You can get some weird results with that. Increment x, increment y. 5 divided by 2, right? 2.5. Let's increment y again. Boom, 1 point, a whole bunch of 6s. Okay. So my point is, again, key takeaways from this, we just demoed some simple mechanics of implementing buttons, implementing, tags and giving them IDs, and a variety of simple math. Yeah, so the key takeaway, again, the quantity held by the var is always going to adapt to what is needed at that moment, right? So 5 divided by 3, if that were an integer, it would display it as an integer, like 5 divided by 1, but 5 divided by 3 is not an integer, so it displays it as this. We don't have to change anything with the var type. Everything in there is already correct. Okay. I'm going to go back to slides if I can push this out of the way. There we go. Okay. So variables and functions, some simple stuff there. Okay. Now sometimes, just like in Java, functions will return values. They'll send a value back. And the typical way this is done, not the only way, but the typical one, they accept some input parameter, they perform some operations, compute a result, and send that result back. Now within JavaScript, just like Java, a function that returns a value can usually be treated equivalently as the value itself. Okay, so for example, if I wanted to do this, I could put in another button. Okay, so let's do this. I'm gonna lift this one first, this button. One more, right? So this button type is a button. We look for what's in demo, but we're gonna set another one. And our inner HTML is get squared. So I'm gonna do a demo XX there. And I'm just gonna basically copy this tag. Whoop, don't need a body tag there, that's strange. Okay. So like I said, HTML is fairly forgiving in terms of failures, but JavaScript is not. Okay, so we have an XX tag there, demo XX, and that's where we're going to show the result of this get squared function. So a function here, get squared, which simply returns x times x. Okay, so I'll put that, I don't know. I'll make it the first one, whatever. Okay. So if somebody presses this button, right, the one that will be labeled x to the second power, the on-click on that says document get a demo XX. It's going to set its inner HTML. So I have a new paragraph tag it's going to be below this x divided by y one, it's going to display the results of this get squared function. Okay, so get x squared. So what will happen, somebody clicks on that. The first thing that needs to happen in order to assign something to this inner HTML, I need to find the result of this function. So I go down to the get squared function. It says return x times x. Okay, that's what this function sends back. So this get squared method is going to return back the current value of x squared, and then that value will get assigned to demo xx's inner HTML. So let's run this. I'll push this down. Okay, so if I do x squared, aha, I have 0. Okay, if I do increment x, okay, there it is, 25, 144, big numbers, right? 23, what's that? I think 529. Yeah, there you go. Okay, that's life. That's life with big numbers. Okay. All right, if I do x divided by y, I still get my infinity. Okay, so we got some math stuff, we got functions, we're learning the basics of JavaScript. Okay. All right, that's math. The next thing, conditional statements. So conditional statements are going to generally allow your program to branch off for various cases, right? So simple one, suppose you enter in your username and password. If your username and password is correct, you're going to be granted access credentials, whatever. If it fails, you're going to get sent back to the login screen. If it fails a certain number of times, then you're going to get locked out entirely, right? So if we wanted to display that, there's paint here. We draw a little sequence here on you. Okay. Okay, so check login, ID, and password. Okay, that would be step 1. We're going to say correct match. And then we'll have another one, fifth failure, right? So maybe you do that. So the first thing we do, okay, this is a check that happens. Somebody puts in something. That result gets tested. Is it correct? Well, if yes, good. You are in. Get to work. Okay, do your business, whatever, then you're fine. If not, do a no here, and we'll do a yes here. Okay, so very simple flow chart here. This is our process. First of all, start here, check your login and password. Is it matched, right? Is it valid with what's in the database? If so, then fine, you get in. If not, then you go down here and it checks if you've tried a bunch of times. Well, if you have if you have tried 5 or more times, then boom, you're locked out, right? You got to call the admins and beg them to let you back in. Otherwise, it goes back and checks again with whatever you enter in next. So that's a simple thing. Now, in order to implement this, this sort of, I don't know, program, we need to assess true and false, right? So that's one thing. That's where our Boolean variables come in. And the other thing is we need statements to branch off according to true and false. So basically something like, if correct, right, dot, 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 go that way, else, otherwise, dot, 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 right? So if it's correct, go this way, otherwise, gonna go that way. All right, so that's where the branching statements come in. Conditional statements, we call them. Sometimes you'll see them selection statements. You need true false variables, and you need the ability to branch off according to whether a condition is true or false. So that's what we have here. Okay. Often useful to perform an action or display content only when some condition is met, right? For example, you go to facebook.com. You don't actually see the content there until you've successfully logged in. So these conditional statements, they can be phrased as if, right? So only do something if the condition is true, or an if else. An if else will do something if a condition is true, or do something different if the condition is false. Right? For example, if we have an if only example, the timer is counting down, right? It starts at like 1 minute and it counts down to 0. Only makes an effect when it actually does reach 0, right? If it's at 59 seconds, 58 seconds, we don't care. All those falses don't matter. It's just when it hits 0, that's when we want something to happen. So that's an example where you would use just an if. On the other hand, you could have an if else, right? So example, for query results, if you find a bunch of matches, sure, go ahead and display them. But if you don't find any matches, you can display some sort of message like your query returned no matches, right? So you want one thing to happen if the condition is true and something entirely separate to happen if the condition is false. Okay, now one thing worth mentioning, in a lot of simple JavaScript programs, the conditions are going to be implicit, right? Like on click. So essentially with the on click, you're basically putting in a conditional statement, but you're saying, if the event that I'm checking for has just happened, then do this, right? But way down in the guts of the machine, yeah, it's a kind of conditional statement going on there as well. Okay. So basic conditional statement is if for only performing an action when the test is true. And the syntax for that is if test action if true, right? So you have this function here is positive, and you get this parameter x. If x is greater than 0, return true, right? Easy. When one action happens if the condition is true and another happens if it's false, use an if-else pair. Okay, so for example, and the syntax there, you have an if statement, then you have an else statement. So if you have this function get the sign for your variable, you have a parameter x. If x is 0, sure, return positive, right? You put that inside squiggly brackets, and if x is positive, you return positive. Else, if x is 0, return 0, else return negative. Okay, so the basic nesting structure on this. So we have something like, again, we'll do this example. So function is positive, and it gets an x. If x is greater than 0, whoop, return, I'll put it in the brackets, return true. Else, okay, and we could do it, we could embed it in another set of brackets like that. Else, if x equals 0, return false. We just do else return false, I guess, the way I phrased it here. Okay. So this part, right? If the condition is true, do this. If the condition is not true, do this, right? And within any of these, you can nest as well, right? So you could say something like, if X is greater than, I don't know, 1,000,000,000, okay, return, return true and very large, okay, else return true. Okay, so you can nest various things if you have multiple cases you want to cover. For example, if you want a very large number to return a different message than a smaller positive number. Okay, so that's the if and the if else. The important thing on those is you remember an else cannot exist, an else statement cannot exist independently of an if. Okay, so you can have an if by itself for action only if condition is true. You can have an if and else for action on true and false, different actions, but not just an else, right, for action only on false. Anyway, the idea with that is anything you were going to do that was only on false, well, you would flip around the condition and have it be true, right? So if you wanted to only have something if it's positive, right? Wrong calculator. I don't want calculator. Okay. If x is 0, greater than 0, return true, that's fine. But if I wanted to flip this around and say, if x is negative, right? Okay, I do is not positive. I wouldn't do something like else, right? Because it would be else what? It wouldn't make any sense, right? So instead, I would just say, I would phrase this as being true. I would just say if x is less than or equal to 0, right? Not positive. Okay, we got a chat here. What's happening? Braces. Okay, so these are called blocks. We have a question here. What are the things inside the braces? So if we have a set of text like this inside squiggly brackets, it's called a block. That is the technical term. Okay. Yeah, block. Okay. So that's ifs and elses, right? Now we get into a bit of the logical stuff. But in just a second, we're gonna do a little bit of that in our little bit of code. So all your basic ones are here is conditional operators. So greater than or equal to as double equals. The single equal sign is reserved for assignment. This is a very common JavaScript error, right? So if you want to test if two quantities are equal, use the double equal sign. And then not equal to is exclam equal. Not the Excel not equals, right? So in Excel you would do a less than and a greater than, but not in JavaScript. In JavaScript, not equal is exclam equals, and of course less than or equal to. Now, because var is inherently untyped, JavaScript also has the interesting twist. It includes type matching operators. So if you have a triple equal sign, that means equal and the same type. So even though var is a single type, it encompasses all the different types, right? Your browser is still going to know that this floating point number is not the same thing as an integer, is not the same thing as a string, right? So if you want to check if they're all equal in the same type, you use that triple equals. If you want to use not equal or not the same type, right, then it would be exclam equals equals. We'll talk a bit about that in a second, but here I want to just fire up this conditional thing. Yeah. Something's going on there. Let's see. just going to lift this. There we go. I don't want to do it in Edge. I've been having a lot of problems with Edge on this machine lately for reasons I do not fully understand. Okay, but I'll just use it over here. Okay. So here are comparison operators, right? There's just a whole list of them, and we can do a try it yourself. Okay, so here it asks input your age, click the button. So what are the things? Function, my function, var age, votable age, blah blah blah. If we say less than 18, it'll say too young, right? Otherwise, old enough. So this is what's called a ternary operator. It's a bit of shorthand. So the question mark, it's going to say, is it true or false? If it's true, we go to this consequence. If it's not true, we go to this consequence. Okay, so votable is basically a string, and depending on whether age is less than 18 or not, it's going to have different possible values. Okay, and then at the end, we display that. So input our age, let's say 99. Okay, try it. Boom, old enough to vote. Okay, how about 7? Ah, too young to vote. Oh no. All right, how about 15? Ah, still too young. How about 25? All right, how about 38? You get the idea. Okay, now this here, again, this ternary operator, it's a little bit of a shorthand for this, right? So we could have, say, if we're gonna put in the equivalent code here with a simple if else. If age is less than 18, okay, then we can just say votable, we'll put it in a block. Okay, votable equals too young. Else votable equals old enough. Okay, so this, right, is obviously more compact, but this is what we're testing here. Okay, this is the same thing. So we run this, do the same thing, try it. 18 is old enough, 17, too young. Okay, same thing here. Okay, you don't really need to know ternary operators. They just save you a little bit of space, but until you get used to them, they're a little weird. So I'm trying to teach people the basic mechanics of ifs and elses. If you're like, yeah, I can do ternary operators, that's easy. That's, I've done it before in some other language. Fine, go for it. There's no penalty. But yeah, trying to keep it simple to display what's going on and doing it this way. Okay. So this key point here, conditional operators are applied after all arithmetic operations are complete, right? Well, let's think about that for a second. So we have, within our order of operations, math happens first, okay? Conditional operations second. Well, reason why. If you imagine if you have something like, I want to check if x is less than y plus 2, I don't know. Well, I have to evaluate this, right? I have to evaluate this y plus 2 before I can determine if x is less than y, right? If I tried to do it this way, if I did, oh, is x less than y, and then add 2 to something, that doesn't make any sense. Okay, so I have to fully evaluate this side, have to fully evaluate that side. Only at that point, right, once that's done, different color is needed. Only at that point, once I've done that, can I also evaluate whether the difference, right, whether the inequality is true. So math happens first, and then the conditional operators. Now, there are other mechanisms in JavaScript where you can test for groups of conditional operators, right? So imagine if you have a set of functions that could be true and true and true and false, and you want to see if they're all true or all false, something like that. So simple example, right? Let's embed a new thing in here. Correct match, or what else? Suppose I want to do that in a single statement. I'm thinking here for a second. Yeah. So exists in database and correct, right? That might be something I want to do, because if it doesn't exist at all in the database, I might return a different message. I might, instead of saying the password is incorrect for this ID, I might say something like this account no longer exists. I can give you that message. Okay, so something like that, I might want to test multiple things, and they could be treated differently. So let's look at this, Boolean operators. So Boolean operators can check between groups of true and falses. So we have a logical and operator. For example, A and, that's what that double ampersand there is. A and B is true if both A and B are true. Otherwise, it's false. So just like in real life, if you might say, I will walk to wherever I'm going if the walking distance is reasonable and the weather is nice. If both of those conditions are true, reasonable walking distance, nice weather, then they're both true and I go do my thing, right? If either one of those is false, then the test is resolved as false and I don't walk, right? If it's 20 miles away, it's not reasonable walk, I'm not going to do it. If it's raining hard, I'm not going to walk either. Logical or, in that test, A or B is true if either one is true. They don't have to both be. But if they are both false, then the expression resolves as false. For example, you might say, I will go to UIC if, what else? What's an or for that? Well, I'll make the trip to UIC if my professor requires it, or I want to meet some of my friends, right? If either one of those is true, I'll go to UIC, right? There's some meeting going on with people, or I have to go there for a class. Sure, I will go there. Otherwise, if they're both false, if my professor is not requiring it and I have nobody to meet there that day, then yeah, I'm not going to go. Okay, so, and or if any of them are true, then the entire expression is true. Otherwise, they're all false. You also have a not operator, which toggles a Boolean value. So not A is true if A is false, not B is false if B is true. So whatever the current true or false of A or B is, not just gives you the opposite. And these kind of Boolean operators get applied after all your conditional operations are complete. So again, let's go, we'll give a password thing. I saw there was a question. Oh, okay, never mind. Yes, they do exist. Okay. So we'll go, we'll do a little something in Paint here. So we'll do a login thing. Check login ID and password, okay? So I can do something like if, right? We'll do a thing here. ID is valid and ID, let's see, password matches ID. We're doing some pseudo code here. It's not real code. It's just displays the logical flavor, right? So if the ID is valid and the password matches the ID, then great, you get in. You are granted access to your account. Great. Okay. So in this, both of these have to be true. Okay, so that's an and. If either one is false, right? So if true, boom, I go there. False. That's fine, I guess. Go down here. Whoop. Okay, now what could be false? Well, there's a couple of things. Whoop. What could be false? Well, we're going to figure that out here. Okay. So the next thing on the false, ID is not valid, password doesn't match, right? So those are two possibilities. So I could say if ID not valid, right? So if I don't find it, then I go one way. And then I could do the catch-all, right? I could say, I do an or statement. If, oh no, that's what I want to do. I'll do this one. Sorry. There we go. I have my or. If ID is not valid or, right, attempts is less than 5, right? If either one of those is true, I go back up here and there's no penalty, right? I just try again. So if that's true, I go there. However, if the ID is valid, if, right, else, right, if ID valid, then I have to check again about the attempts, right? So if the ID is valid and I just do this, if attempts greater than or equal to 5, then I get locked out. So I increment lock, right, increment the attempts count, and then I do that. Okay, so these are some simple ands and ors and where they're useful. Okay, so like right here, let's put in the annotations. Both conditions true, then the and statement and expression is true. Okay, so if the ID is valid and the password matches the ID, if both of those things are true, then I go over here, I get granted access to my account. Okay, if it's false, right, if the ID is not valid or the password doesn't match it, then I go down to this thing. So if either condition is true, the or expression is true, right? So if the ID that I give in isn't valid, well, they're not going to, update the number of attempts for that because they don't know which ID I'm trying for. Okay, so they wouldn't know which account to lock me out of. So if the ID is not valid, I go back that way. Or if the number of attempts is less than 5. If I made fewer than 5 attempts, right, then I say, okay, you can try again. I guess I should always increment the number of attempts. I'm trying to put it that way. Okay, whatever. That's fine. I leave it that way. Well, it's not perfect, but I'll live with it. Okay, this number of attempts should probably be up here. There we go. You could make it work a little better, but I'm just really trying to do the ands and ors here. Okay. Questions on this stuff? This is kind of where I wanted to leave off for the day. I didn't want to throw in loops. Let's go back to the code then. So I'm asking for questions. If there are any questions out there, I hope all of this makes sense. I'm going to put some stuff in chat here. Okay, so key takeaways. Number 1, order of operations happens as first math, then conditional operators, right? Conditional operators, operations, then Boolean operations, right? The and, or, not, those, okay? Because you have to do the math before you can evaluate greater than or less than. You have to evaluate all of those conditional operations before you can evaluate groups of them. Oh, that went privately. I didn't mean for that to go privately. They're in the slides. Right, sorry, I meant to do that here. Boom. Okay, so for example, and for or, by the way, that vertical line, that should be just below your backspace key on the keyboard. Okay, so do a shift and whatever with that. So there will be a backward slash and then shift that key should be the vertical line, and just an exclam for not. Okay, so that's that. Yep. And then what else? What else have we covered? Done math, done order of operations. That's fine. Okay, so let's bounce back to our code for a minute here and get rid of this, get rid of that. This is the one I want. Okay, so for this one, we're going to show you what happens. What shall we test? Let's do one more button. Well, let's just do a simple x is greater than y. That'll be fine enough for now. Okay, button type button. We'll do x equals y. We'll do an x is greater than y. That's fine. We'll do that to start. X is greater than y. Okay. What's the function I want to go to there? Okay, we'll just do greater. We'll call it, I don't know, xgy, x greater than y. We're not very motivated. I'm not very creative today. You know what? We could just do this. We could do document get element by ID. Oops, sorry, by ID. Which one do we want to do? Let's do demo XX. Sure. Demo XX. And we'll see inner HTML equals x greater than y. Okay, so whatever this evaluates to, that's what we're going to, that's not what I wanted. Whatever that evaluates to, that's what's going to display there, as long as this is all correct. So let's see, let's run it. We have our x greater than y. False, right? X is not greater than y. Well, let's increment x1. Boom, now 1 is greater than 0. True. Hooray. Okay, so simple stuff, right? These are all the building blocks of bigger programs, but that's what we're doing here. All right. So what did we do as far as this? Well, we created a whole bunch of buttons. We created some paragraph tags, and we created some very simple methods, very simple functions. Anytime we clicked on one of these buttons, it did something, right? So reset X, increment X, decrement X, reset Y, increment, decrement, multiply them together, divide them. NAM, that stands for not a number. Do this test, you can square X, lots of good stuff. Okay, I'll grab this code and post it up, and if you want to play around with it a little bit, that'll be fine. Okay, but I'm going to stop the screen share. I'm going to do a last call for questions. Any other questions on any of this stuff? We had a few. I hope it all makes sense. Okay, so at this point, you know, you should understand the var type, okay, JavaScript math generally, okay, and then 3 conditional statements and Boolean operators, okay? And those, if you've taken IDS 201, whoops, sorry, I keep putting this in private chat. I got side conversations. Okay, so everybody, boom, okay? If you've taken IDS 201, this should all be pretty familiar with a few small differences. Okay, but just the fact that you don't have to super worry about typing in JavaScript is a very handy thing. While we have a couple of minutes, I'll mention one last thing. The reason why they don't do typecast, this sort of serious type checking in JavaScript. JavaScript, these programs, they weren't run in a web browser. They tend to be relatively simple. You just want them to be quick and easy to code and to not get hung up on some weird, type based error. Whereas JavaScript is more serious. It's applications running on the back and servers, and you want to be a lot more careful with the data types in that sort of situation. You want to make sure that nothing goes awry. But also Java programs tend to be bigger, because Java programs tend to be bigger, tend to be more memory intensive. If you had to, okay, this sort of type flexibility in JavaScript, it entails a computation cost, because JavaScript continually has to check and see, is this variable in the correct type? How am I going to manage that? And that means anytime you do some stuff, there's going to be a few extra checks where you look at the kind of variable that it is. Now, because these programs are kind of small and cheesy and running in web browsers, that computational cost is not a very big problem. But if you're doing these heavy-duty applications that are running on servers, then yeah, you want to be relatively more efficient. And that's the reason why you do this type checking in Java and other languages like C++, is so that everything runs faster, right? If you have a whole lot of connected users and a lot more complicated programs going on, cutting that corner would actually cost you a lot of time and make your applications run slow and sludgy. So that's basically the issue. Okay, I thought there was a comment. So I have a question here. Somebody's asking about assignments. I thought I posted the first assignment, did I not? Yeah, assignment 1 was posted. I thought I put out an announcement about that. So yeah, if you haven't looked at it yet, assignment 1 is posted. When's it due? Let's find out. I don't remember. Oh yeah, it's due Wednesday. It's pretty simple though. But yeah, I posted that out last week. Okay, so where's my Zoom? There's my Zoom. Okay, so yeah, if you're still here and listening and you're awake, assignment 1 is due Wednesday. Okay, if you need an extension, whoop, damn it, I keep on doing this. It keeps bumping me up to, okay. Assignment 1 is due Wednesday, okay? And if you need an extension, please contact the TA, okay? Because, 48 hours in advance, you can ask that. Okay. Well, that's what I got then. I am stopping the recording. It's been a hoot. We'll see you on Wednesday.